I go out and do a lot of redos for electrical. I see things that, to me, it's the absolute basics that'll get you in trouble. I'm gonna go over a few things that, even though we don't usually get electrical inspections from a city inspector, there's certain things that they open a box up and see, they're gonna just eat you alive, okay? Starting with how electricity works. If you don't know how electricity works, you might as well not even open an outlet up. I had an old-time union electrician explain to me one time about electricity and water. It's basically the same theory. If you've ever been to a fair and you've seen the little ducks in the water going around, and you throw the little hoop on its neck, that's a good way to describe electricity. You've got a channel with water in it going around and around, okay? There's the width of it, and then there's the speed of the water moving, okay? Hold that thought for a moment. This is the same thing. You got the pole outside, you've got the wire coming into your house. It's what it is, it's two hots and a ground, okay? It comes into your panel. Through that panel, it goes all out into your house. But the bottom line is, at the end of every circuit, it goes back out, ground. That completes the circuit. That's the circle, okay? I just use a circle because it's easier to show. Every fixture, there's a line and a load, which is in and out. Your line is always the power coming into the fixture. When you start getting into ground faults, if you wire it wrong, the ground fault's not gonna work right. You'll see on the back, line, load. You always go line in and load out where it says.
John, I'm sorry. When you say line in, that means you're hot?
Line in is the hot wire coming into your house, okay? It comes out of your panel into whatever fixture you're firing up. You got all these hots coming out, okay? But on the other side of the hots, you got the white, which you see as white, going back out. It always makes a circle. A switch is like putting a board in the water and stopping it. You just flip the switch, you stop the water from moving. That's the best way to describe a switch. It's stopping the power because inside the switch, it's actually like moving that apart from each other so they're not touching. Turn the switch on, creates the circuit, you get the circle again. Anything that interrupts the circle, you're gonna have power issues. You see amps and you see volts, okay? If everybody doesn't know, that's a 14 wire, that's a 12 wire. That's for a 15 amp circuit and that's for a 20 amp. In this room, that's probably all you guys will ever have to really worry about. In a home, at our level of what we're doing, that's really the only two you guys probably need to worry about. A 15 and a 20 amp circuit. Typically, your 15's your lighting, your 20's your outlets, which means you go into an old house, first thing I do is I go to the panel and I look at the breaker. You're gonna have a number on the breaker. It's either gonna be a 20 or a 15. If it's a 20 amp breaker, you cannot go in this house and pull it out. Let's say I wanna put an outlet there. I'm gonna tap into here, pull it over and put it there. If you're in a 20 amp circuit and you put a 14 wire and an inspector sees that, it's not gonna be good. These wires are rated, there again, that's the wire, the size of the wire, okay? The volume of water is your amps. So if it's really wide, so a 15 amp circuit is thinner wire than a 20 amp wire. It's a thicker wire, more water, more power going through it. The speed of the water going around is your volts. That's a kind of a good way to understand that. It's a circle, water, power's going through it. A switch breaks it. I'm seeing a lot of that. I'm seeing a lot of 14 wires on 20 amp circuits, which theoretically you can cause a fire doing that. You'll melt the wire.